Hi everyone, I'm putting together this presentation as part of a research project I am doing for my SARE grant. So today I'm going to take you through building a gravity-fed spring system for my farm, Wayward Springs Acres. Our farm name is Wayward Springs. The reason we have named it that is because we have a lot of natural running springs in our hillsides that run through gravel beds created by the glaciers that traveled through our area. These springs run year-round. Even in the driest years, they continue to put forth water. In fact, it seems like the drier the year, the more water they tend to put out. So we're going to talk about how we use these, capture them, and use them for watering livestock, or in this case I'm doing it for a greenhouse, putting in a hydrant and watering plants and things we're growing year-round. The system that's always been used on my farm is very simple. It consists of a catchment tank up at the top of the hillside where the spring is usually gushing forth, and then a pipe comes out of the bottom of that underground, well below our frost line, to a hydrant at the point of use. And you always want to maximize the height differential from the catchment tank at the top to the hydrant. So here you can see the spring that we're going to be putting the catchment tank in. Up here at this arrow is the location where we'll be digging the hole and putting in the catchment tank. You actually can see up over here is an older one I did a few years ago that goes over this way to cattle watering hydrant that I use in the pasture for cows in the summertime. That one I don't use year-round, so I was maybe a little less careful with keeping it insulated and sealed up. It's a steel culvert that has slots cut into it. But this one I'm planning to use year-round, so I'm going to make sure it doesn't stick out of the ground as far, and I'm using a plastic culvert that I can insulate the lid and top of so that it doesn't freeze in the wintertime. You guys want to select the site based on a spot that's at the head or the top of the spring, so you can get the most height, gravity down to where you're going, but also you want to be close to the source where the water is coming out of the ground so that you can capture as much of it as possible. So the first thing you want to do is identify where you're going to be routing your trench and dig that. You want to make sure that your trenching depth is deeper than your frost depth, especially if you're going to be using it year-round. But even if you're not going to, you want to be well below that frost depth, because you don't want to have those water lines freeze in the wintertime and then burst the line or something, and then you have to try to find that location, dig that up the next year. When I'm making a simple system like this, I found it's definitely a lot easier to start with the bottom, the downhill side of the work that you're doing. So this is the bottom of the hydrant. Putting that in, so I've dug down, put in the fitting, connected it to the water line pipe. This guy runs out under the foundation. Here's it's coming out of the foundation. The foundation appears at about a 4-foot depth. And I found that it's easier to start downhill and get this stuff in place before you dig your trench up to the spring, because once your trench hits the spring, all that spring water is going to run down your trench if it's open and make a really big muddy mess, and you'll have a heck of a time dealing with the water that continually fills up the trench, sometimes faster than you can pump it out. Now here I've got the hydrant is in place. In this case I had some nice things I could tie off, some bolts over here, so I ran this wire, wrapped it around the pipe to hold it up straight while I backfill it. You always want to make sure you look at and follow the hydrant's installation instructions. Typically these guys are meant for being installed outdoors in locations that freeze. So they have a little valve down here that when you close it, then the water in the hydrant can run back down and out. So the first thing you want to do is backfill with large rock and gravel around the valve area here, so that water, that little hole in the water doesn't get stuck and plugged up in there, because if it does, then your hydrant can freeze. You want to make sure that you fill with that first, and then you can put your other fill soil in above that. So here's the hydrant. This is actually the foundation, so it ends up getting filled up with topsoil up to about that level. Okay, so we put in our hydrant, that's all done, and now we're looking at putting together the catchment tank. So in this case, I've got an illustration here showing what we have. So you've got on the top, you've got your soil that you'll be excavating out, and then below that we have a gravel layer, and that's where all the water is sitting in that. And so you want to have your catchment tank go down deep enough that you get a good amount of area into that gravel bed with the water in it. And then you'll have perforations or holes in the side of that catchment tank for the water to flow into it and fill it up. And some of the ones on our farm are our old one, probably built in the 30s or 40s. It doesn't have those perforations inside, but the whole bottom is open. So in that case, the water flows in up through the bottom and fills that guy from the bottom. So just the more surface area you have exposed to the gravel bed, the faster the fill rate will be, and the more water you can get out of that. And then we'll have a strainer mechanism here where the water will be able to flow out of that through the pipe connected to the hydrant. So over here I've got a view of the inside of the culvert. This is like a 32-inch culvert that I was able to get used that had some flaws in it, which maybe made it a bad culvert, but perfect for this. So you can kind of see here, I just took the angle grinder with the cutting blade on it, and I cut these slits right into the side of that, and did that a good distance up the culvert. You'll have to kind of estimate how far to do those based on how deep you're planning to go into the ground and where the water level is. There's no reason to have those slits up in the top part up here where your topsoil is, but you want to have them down the bottom where your water will be able to flow into your catchment tank. Once you get your slits all cut in, you can go ahead and add the strainer mechanism that will be connected to your water line. So in this case here, this is just a regular spray tank strainer that you'd put into maybe a chemical tank or something. Of course, you want to get one that hasn't been in chemicals, since you'll be using this for water. And you'll put it in and have it facing down. And the purpose of this is really to keep debris and stuff from getting sucked into your pipe when it's got flowing water. So the strainer creates kind of area of high and low pressure that when particles, dust, sand get to that, they'll fall out of suspension onto the bed down here and not get sucked into your pipe and plug up stuff in your lines. So then on the outside of the culvert here, you can kind of see actually it was crushed and stuff. That's why I got this one a good deal on this one. You'll have a connection point here, a spigot for whatever size water line you have. You want to keep your water line that you choose to be as large a diameter as possible, 1.5 or 2 inch, depending on the distance you're going and things. But the big thing is you don't have a lot of pressure in this system, and the smaller pipe you put on this, that'll really slow the water flow that you're going to get out of that. So you want to keep your water pipe as big as you can. And you'll find that once you do hit that layer, your hole will fill up with water pretty quickly. You can see here, given maybe half hour or so, you'll get a nice pond of water developing in that, and in this location here, it'll fill all the way up no matter what size I dig that hole, until it runs out over the top. There you can see it filled up and flowing over. This can be a problem if you're trying to dig this out. So you usually want to plan to have some sort of a pump around and ready for you to pump that water out of there so you can keep digging, or you might need to dig another trench to let that water run out of, if you have enough of a slope that you can do that, to let the water run away from the area where you're digging. So there you can see, just kind of continuing to dig down. In this case, for a while, I had just a little sump pump, and that would keep up with it. We've got a lot of topsoil that keeps kind of washing in as you're digging. That's what really makes this a hard thing to excavate, is to keep the area around from falling in, because the water is trying to wash everything in here. So what I found I end up having to do when digging things like this is dig as much as I can, and then build kind of a little bit of a retaining wall to stop that. So here you can kind of see the water flowing just into this area. Kind of runs from all around when you're in the middle of the spring. So I don't have a lot of good pictures of how I backfill this, because that was kind of a tricky thing to do while you're digging, getting it dug down. But you can see the top of some posts here. I use like a chicken wire mesh or cattle panels, depending on the size of rocks and gravel, and build kind of a little retaining wall with that to hold the topsoil and the earth back, so you keep digging deeper without everything falling in on you. And then once you have that all stabilized and you get your culvert in place, then you want to start backfilling. Up close to the culvert and stuff, I put in larger rock material that we have around that I can dig up and put in there, and then fill the areas above that with gravel, so you'll get good water flow into the culvert or the catchment tank as you're going. So here you can kind of see I've got it mostly filled up. I've got a little bit of water running in here, and it'll just, if you're not filling fast enough to keep up with that, you'll have water keep coming up and getting in the way where you're working. I also had this weird situation here at a barbed wire fence, and one day I was working on this, next day I came back and there was a bat. He got himself caught on the barbed wire fence. Kind of a strange situation, poor guy. Rough life. So we got the box in place, and here you see I just go ahead and cut that off at the height that I want it. Not too far off the ground, but high enough up that if cows get out or something, they don't step on it or get tempted to climb on it. And see the water in there. You'll get a bunch of filings, shavings from cutting that off. You want to scoop that out, clean out any debris, any dirt, dust that fell in there. And then, then we'll move on to making the lid. So you can kind of see the lid that I put together, just a piece of plywood on the bottom. Put some insulation on this. The top of the water will freeze, of course, in the spring and the winter time, but the water below is not going to freeze because it's running all the time. But putting a little bit of insulation in there will help minimize the depth that ice forms in the spring tank and give you a little bit better water capacity. And so here you go. You can see it, with the lid in place and just sitting there. And one thing too to think about is it's always going to be a wet, mucky spot around here. I did have a little bit of a gravelly channel that I made right over here, so that the extra water, instead of sitting all up here, I can follow that little gravel bed when it gets full and give you kind of a runoff channel that goes down here. All right, so now we've got everything hooked up, plumbed up, and time to test it. So Here, turn it on, let it run for a while. It'll be dirty and icky for a while. Usually let it run for a day or two, let that all get cleared out. And then after it's been running for quite a while, you should do a little bit of a measurement to see how much water you can get out of it. This guy is giving me good 5 gallons per minute. Just use a 5-gallon bucket and see how full it fills up in a minute. And then, depending on what you're using this for, you might want to take a water sample and get that tested. If you're using it for livestock or watering plants in a greenhouse or something, you want to know what you got in your water. I don't intend this for drinking water, so don't worry too much about that for human consumption, but you want to care about that for your plants. One thing to note for us, is we're kind of, our water tends to be fairly alkali, which can be an issue. And so you want to know if that's the case, that you can do some things for your plants. They don't like too alkali water. And yeah, and so there you go. Well, that's kind of an overview of our spring-fed system. We use this for providing water to our greenhouse. We also have these at other areas on our farm, mostly for livestock.